When you gaze up at the night sky, you're looking at a vast cosmic tapestry. Those twinkling lights are stars, each one unique in its own way, differing in size, color, and temperature. Some burn with a blue-white intensity, others with a gentle red glow, and many fall somewhere in between. Our Sun, for example, is a G-type star, bright and yellow. But let's turn our attention to its orange cousin, the K-type, or orange dwarf star, which sits just a bit cooler and dimmer on the stellar spectrum. Orange dwarfs are smaller and cooler than our Sun, glowing with a warm, inviting orange hue that sets them apart in the night sky. In fact, these stars are among the most common in our galaxy. If you could hop from star to star across the Milky Way, you'd find orange dwarfs scattered everywhere, quietly shining for billions of years. Unlike massive blue giants that burn out in a cosmic blink, K-type stars are slow burners. They can live up to 30 billion years, 3 times longer than our Sun's expected lifespan. Their steady, patient glow makes them true survivors in the universe. Because of their stability and longevity, orange dwarfs are fascinating to scientists searching for life beyond Earth. Their long lives give planets plenty of time to develop and evolve, making them prime candidates in the hunt for habitable worlds. Imagine visiting one, like gathering around a cosmic campfire, basking in its steady, enduring warmth. It's a comforting thought, even if it's only possible in our imagination. Of course, we can't actually travel to these distant suns, but by imagining, we can explore the wonders of the universe from right here on Earth. Our curiosity is the rocket that takes us there. So buckle up for a thought experiment. Let's embark on a journey to an orange dwarf star, venturing far beyond our solar system. It's a voyage into a realm of extreme heat, powerful gravity, and intense radiation. Conditions that challenge our imagination and our science. Before we set off, picture this. A K-type star is like the Sun's smaller, cooler, and slightly redder sibling. It may not be as bright, but it's just as fascinating. Still, it's a massive sphere of super-hot gas, with a core where nuclear fusion powers its light and heat. The energy released here is what makes the star shine for billions of years. This fusion process is the engine of the star, releasing a steady stream of energy that radiates out into space, lighting up the darkness. Now, we're about to get up close and personal with that energy, experiencing the awe-inspiring power of the star firsthand. Ready to take the plunge? Let's begin our fall into the heart of an orange dwarf and discover what secrets it holds. To understand a K-type star, let's compare it to our Sun. The Sun is a G-type star, big, bright, and hot, with a yellowish-white glow. A K-type star is smaller, with only 50–80% of the Sun's mass and cooler, giving it that orange color. It's less luminous, emitting just 15–45% of the Sun's light. Planets would need to orbit much closer to stay warm, creating unique challenges for life. Think of the Sun as a roaring campfire, and a K-type as a smaller, gentler flame you can sit closer to. This difference shapes the diversity of worlds in our galaxy. Our imaginary spaceship arrives near an orange dwarf, a star smaller and cooler than our Sun, yet still burning with unimaginable energy. Its light glows softly in the darkness, a beacon in the endless void, inviting us to explore its mysteries. It appears as a glowing orange marble in the void, suspended in the blackness of space, radiating warmth and power. We don our indestructible suit and step out, leaving the safety of our ship behind. The airlock hisses shut, and we are alone, floating in the emptiness. Beginning our slow fall toward the star, we surrender to the gentle tug of its gravity, drifting ever closer to its fiery heart. At first, we float in silence, surrounded by the infinite stillness of space, the only sound our own breath echoing inside the helmet. The star is just a distant disk, a tiny sun against the backdrop of eternity, its true size and power hidden by distance. Gravity is faint, barely noticeable at first, but as we drift closer, its invisible hand grows stronger, pulling us in. The star grows larger, and its pull strengthens. The warmth increases, seeping through even the toughest suit, like standing in spring sunlight after a long winter. The sensation is gentle at first, a soft glow that hints at the power beneath the surface. Soon the star fills our view, its surface a roiling, boiling sea of hot gas, alive with motion and energy. We see flares erupting and dark star spots, each one larger than entire planets, dancing across the surface. These are signs of powerful magnetic fields, twisting and snapping, shaping the star's fiery atmosphere. The surface is alive, dynamic, and immense, an ever-changing landscape of plasma and light. Our path curves as gravity accelerates us, drawing us deeper into the star's embrace. The silence is replaced by the overwhelming presence of the star, its energy humming all around us, filling every sense. We're falling into a living, breathing furnace. The scale is humbling. Our entire world could vanish in its fires. This is no ordinary fire, but a cosmic inferno, fueled by nuclear fusion and the raw forces of nature. We're about to experience the true power of a star, a force that shapes galaxies and gives life to worlds. The journey has only just begun. Ahead lies the heart of the star and mysteries beyond imagination. The heat intensifies as we approach, our suit's cooling systems push to the limit. Temperatures soar to thousands of degrees, far beyond anything on Earth. We're bombarded by a storm of photons, the product of nuclear fusion deep within the star. The light becomes blinding, the star an endless ocean of orange brilliance. Space itself seems to shimmer from the energy. Our suit's gauges show unimaginable temperatures. Lava would vaporize instantly here. Rock would boil away. Everything becomes plasma, a superheated soup of charged particles. The normal rules of matter no longer apply. We're entering a realm where only energy and plasma exist. The star's power is overwhelming. We're a speck in a cosmic inferno. The environment is utterly alien. Our suit is the only thing keeping us from instant destruction. We're on the edge of the star's true fury. Heat isn't our only enemy. Gravity is growing stronger with every second. As we approach the star, the invisible force pulling us in becomes overwhelming, far beyond anything we've ever experienced on Earth. The star's mass creates a gravitational field hundreds of thousands of times more powerful than Earth's. This immense gravity dominates everything nearby, shaping the very fabric of space and dictating the fate of anything that comes too close. We accelerate rapidly, pulled in at thousands of kilometers per second. The sensation is dizzying, like falling endlessly, but with no hope of slowing down or stopping. Tidal forces threaten to stretch us, spaghettification, as scientists call it. The difference in gravity between our head and feet grows so extreme, it could pull us apart, atom by atom. Our suit protects us, but the strain is immense. Every layer is pushed to its limit, fighting to keep us in one piece as the forces outside try to tear us apart. Gravity here would crush anything. On the surface, you'd weigh over 7,000 kilograms. Even the strongest materials on Earth would buckle under this pressure, collapsing in an instant. Light itself bends under this force, warping our view. The star's gravity acts like a lens, distorting everything we see and making the world around us look surreal and twisted. The acceleration distorts our sense of time and space. Seconds stretch and warp, and our perception of reality begins to unravel as we're pulled deeper into the star's grip. The star's surface rushes up to meet us. Waves of energy and radiation surge outward, making the environment even more hostile and unforgiving. Gravity, gentle on Earth, is a destructive force here. What feels like a comforting embrace at home becomes a merciless, crushing power in the heart of a star. It holds the star together and pulls us to our doom. The pressure is relentless. There's no pause, no relief, only the constant squeeze of unimaginable force. We're experiencing the raw, crushing power of a star. Every moment here is a battle against forces that could destroy us in an instant. There's no escape from this cosmic grip. The star's gravity is absolute, and once caught, nothing can break free. We're being drawn into the heart of the orange dwarf, where gravity reigns supreme and the true power of the cosmos is on full display. Now radiation joins the assault. Stars emit not just light and heat, but deadly X-rays, ultraviolet, and a fierce stellar wind. On Earth, our atmosphere shields us, but here we're exposed to a lethal torrent. Our suit's alarms blare as radiation levels skyrocket. This energy would shred DNA, destroy materials, and end any real journey instantly. K-type stars are calmer than some, but up close, even their gentle radiation is deadly. The stellar wind, plasma moving at hundreds of kilometers per second, sandblasts us with subatomic particles. Our suit barely holds, deflecting unimaginable forces. Heat, gravity, and radiation. The star attacks with everything it has. We reach the photosphere, the star's visible surface. It's not solid, but a dense, blinding layer of gas. Crossing it, we plunge into a superheated, high-pressure plasma. The pressure is thousands of times greater than Earth's atmosphere. Moving feels like swimming through burning molten honey. Gravity drags us deeper, while convection currents toss us in swirling, slow-motion storms. Light surrounds us in every direction. There's no up or down, only deeper. Magnetic fields twist and snap, creating powerful electrical currents. We're caught in the star's churning interior, a nuclear furnace of unimaginable violence. Our suit is the only thing keeping us from instant annihilation. We're swept up in the star's convection cycle, rising and sinking with massive bubbles of plasma. The journey is chaotic, overwhelming, and inescapable. We're now part of the star's inner workings. Survival is impossible. Dissolution is inevitable. Our suit finally fails. The forces are too extreme. In a microsecond, we're vaporized, our atoms stripped and ionized. We become a cloud of plasma, indistinguishable from the star itself. Our atoms are swept deeper by convection, perhaps reaching the core. There, some may fuse, releasing energy and becoming part of the star's light. Our consciousness is gone, but our matter endures, recycled in the cosmic engine. We become starlight, part of the orange dwarf for billions of years. When the star dies, our atoms will be cast into space. They may help form new stars, planets, or even life. In the universe, nothing is truly lost. Everything becomes something new. Our journey ends, but the lesson remains. K-type stars are powerful, ancient, and incredibly common, prime candidates in the search for life. Their longevity offers a stable window for life to evolve, far longer than our suns. Billions of these stars fill our galaxy, each a potential cradle for new worlds. Their calm nature and long lives make them ideal for astronomers seeking habitable planets. Next time you see an orange star, remember, it's a marathon runner of the cosmos. While falling in would end you, these stars may be the beginning for someone or something else. They represent possibility, endurance, and the ongoing story of the universe. As we explore, we keep asking, are we alone? The answer may be circling a distant orange dwarf waiting to be found.